First year we are using the up to class 12th level, up to 12th level we are using. After the second and third semesters, they are using the course just like a BSc BEd. There is a what course we have, Riemann integrals and differential trigonometric formula. This all area we are doing. It's very challenging, sir, but we are, and also we are using the math like
Jugs, sir, actually, sir is asking the syllabus of GeoGebra also, isn't it, sir? So that you can share here, sir, if time permits later.
GeoGebra we are using as a tool.
As a tool. Yeah, you can share the syllabus actually.
It will be very nice, yes.
We don't have any. First year we are using the up to class 12th level, up to 12th level we are using. After the second and third semesters, they are using the course just like a BSc BEd. There is a what course we have, Riemann integrals and differential trigonometric formula. This all area we are doing. It's very challenging, sir, but we are, and also we are using the math like
Jugs, sir, actually, sir is asking the syllabus of GeoGebra also, isn't it, sir? So that you can share here, sir, if time permits later.
GeoGebra we are using as a tool.
As a tool. Yeah, you can share the syllabus actually.
It will be very nice, yes.
We don't have any specific syllabus. We also developed one manual, sir. Just like a practical manual book on the basis of PSC as a PSC program.
I see, I see.
So we also developed the one manuals. So there is a up to class 11, 12th and BSc levels there is a lots of practicals.
Yeah, actually, we also used to conduct this 5-day workshop. In that one, it will begin with beginner level, which introducing the basic tools of GeoGebra. Then first 2 days it will be go like that, and they will be familiarized with the GeoGebra tools. Then it will go to the developing of applets, which is from their textbook. Teachers will develop their own applet, and up to 3D it will go. But the scripting and other things we never introduced to the so far we have not introduced to the teachers training programs. And our student teachers used to prepare that one.
This is the one manuals and development of mathematics practical manuals for the BSc BEd level. So this is our manual developed on the through BSc program. So there is a lot of practicals given inside that there.
I think along that Maharashtra also, I think they have given based on IIT Mumbai, they have given long term, means 1 year training every Saturday or monthly 2 days or 3 days, like that something. Professor Aikya Rana was telling they were giving training for GeoGebra for school teachers on Saturday, Sunday, like that. Not state program.
Same way, yes, sir. One professor IIT, retired IIT professor Mumbai.
Aikya Rana.
Sunday, 6:30 to 7:30, they are giving ideas about our students. Every Sunday they are giving 6:30 to 7:30 about the GeoGebra. So if you want to that link, so I will send you.
Sure, definitely.
So Vasalva sir, can we start, sir, now?
Yeah. Can you hear me, Madhu?
Yes, sir. You are very much audible, sir.
Good morning, Shirai, sir.
Good morning, sir. How are you?
Madhu, can you
Good morning, sir. Vasalva sir.
Madhu, we are going to have the session till 10:45 and then question answers follows, right?
Yes, sir. 9:30 to 10:45, then question answers will be there. So that will be. So I will just. Our faculty Rekhu is there. Rekhu will moderate the session in the beginning, and he will then chairperson can take over.
Good morning, one and all. Welcome once again to 10th National Conference on Mathematics Education held in RI NCRT, Mysore. I would like to welcome Dr. Shailesh Shirali, sir, Director of Sahyadri School, KFI, Pune, to provide a keynote address. And also, I would like to welcome Professor A.K. Vasalwar, sir, Department of Education in Science and Mathematics, NIE, New Delhi, who is chairperson of this session. Now I hand over to Professor A.K. Vasalwar, sir, to chair this session.
Good morning to all. Good morning, Professor Shirali, and a very warm welcome to you all. Today, in the current scenario, all over the world, we are concerned about the understanding part of mathematics for all stages of school education. And in this particular context, we are trying to provide the student a platform for independent thinking, where they can work it out for themselves and try to think and interact with the peers, with the teachers, and so on, so that their understanding of mathematics grows. And but unfortunately, very little exposure is given to the students in this particular area, and so they are losing, particularly the open-ended exploration that needs to be encouraged among the students, and that's why the valuable learning opportunity is lost. Moreover, the historical perspective, in the sense that the students or the learners need to realize that mathematics has not come from the heavens. It is the effort of the human beings, and it goes on and on. And so student and teacher can actually contribute to the subject itself as they interact with each other. So an awareness of the history of mathematics, on the other hand, can we bring these two together so that the understanding and learning levels of students, the teachers as well, will grow as the time passes. And this is the gist of the today's talk, which we are going to have from Professor Shirali, who is presently the director of Sahyadri School, KFI, Krishnamurti Foundation, India. Dr. Shirali did his PhD from US and then returned back to India. He has a deep interest in mathematics and mathematics education, and since 1987 he has been involved also in the Mathematical Olympiad movement in India. He has taken part in the training programs for the Indian IMO teams each year from 1989 till present. He also serves as the Council of Editors for Resonance, an expository journal for science and mathematics education, published by the Indian Academy of Sciences, and is the founding editor of Samasya, problem-solving journal for school and college students, published by Leelavati Trust. He is also the founding editor of At Right Angle, a journal published by Aziz Premji University. He has also authored many books, including a primer on number sequences, first steps in number theory, a primer on divisibility, a primer on logarithms, etc. He is an ace number theorist and a great person who is contributing to the field of mathematics education presently. So I welcome you, sir, and I hand over this digital platform to you till 10:45, after which we can have a question-answer session. Thank you so much.
Thank you very much for this very kind introduction. I think you have been very flattering. And thank you also to the RIE and the NCRT for inviting me to present this talk. So without any further ado, I'm going to share my screen. Yeah, please let me know if you can see it clearly. Yeah, can I get a confirmation that it is visible? Yeah, okay. So, yeah, all right. Yeah, may I request a muting of mics, please? I'm hearing a lot of sound. Yeah, so as you just mentioned, an awareness of history is by and large lacking at the school level. And equally, the use of exploration, open-ended exploration. And it seems to me that both these are underutilized sources and should be brought into school, teaching of school mathematics. And I would like to present a situation when they actually come together. So this is my theme. First of all, let's look at this question of independent work and open-ended exploration. I think probably all of us will agree that in school teaching, there is very little emphasis given to independent work. This is so in all subjects, not just mathematics. And of course, it is so in mathematics too. And I think a very valuable learning opportunity is lost as a result of this. Because exploration it can be an eye-opener. It reveals things which perhaps the teacher himself or herself would not have expected. The student discovers new aspects of himself, and it's an extremely important resource. And I think we need to make use of this much greater. And then there is the history of mathematics, which is, as just Professor Vazava just said, it's not something which just dropped out of the heavens. There's very little exposure to historical themes in mathematics in our country. Probably in most parts of the world, there are very few places where there's any emphasis given to history. But of course, I don't mean just history taught in terms of this happened in this century and that happened in that century. It needs to be integrated into the very teaching of the subject. So that, and in particular, it needs to be integrated with problem solving and with exploration. Because I think it makes sense, it will carry meaning for the student when it is integrated in that way. So, as I've written out here, there's very little awareness that mathematics is a human endeavor. It means human beings have struggled, grappled with difficult problems, formed mathematical concepts, mathematical theories, discovered a lot of beautiful results, and it's a subject which has grown and is still growing. And also, we need to have this awareness, both the student and the teacher, that it is possible for each one of us to actually contribute to the subject. I think there is a widespread feeling at the school level that my only role is to learn the subject. That is, I just listen to the teacher or read the textbook and that's all my role is. But maybe I can myself discover something of some creative importance. And for that, I think the exploration is absolutely essential. So therefore, I have written this question out here. It's a question. Can we use these two themes, history and open-ended exploration, to enhance the teaching of mathematics? As I've written here, exploration and investigation form a vitally important aspect of learning. And equally important is the understanding that mathematics is a human endeavor, that it is part of human culture. And can we somehow bring these two strands together? I feel we can, and they will mutually benefit each other. So I'm going to take 3 case studies here, and they are all fairly well known. So forgive me, my apologies if they are it's a repetition of things which you know. But I would like to bring them in combination with exploration, not just as historical facts in themselves. So the first one is about Fibonacci numbers. So here, of course, the sequence of Fibonacci numbers is extremely well known. 0, 1, 1, 2, 3, 5, 8, and so on. And generally, they are defined using an arithmetic property. And what is that property? Each term is the sum of the 2 terms before it, after the first term. So it's an arithmetical property. But it turns out that they can also be defined in a combinatorial setting. And this actually happened in ancient India. And now a nice challenge offers itself to the teacher. Can I devise a nice activity, nice open-ended exploratory activity by which the student can discover this fact for himself? So here is one possibility. First of all, I'm going to look at this question of compositions. A composition of n basically is when you express n as an ordered sum of positive integers. That means I arrange some positive integers in a row, put some plus signs in between them, and the total has to add up to n. So for example, let's look at 3. These are the compositions of 3. You can write it as 3 by itself, or 2 plus 1, or 1 plus 2, or 1 plus 1 plus 1. And so you see there are exactly 4 ways of doing it. Notice that order matters. 2 plus 1 is not the same as 1 plus 2. So now we define, let's say we are interested in the number of different compositions of n. I let an denote that number. So A of 3 is 4 because there are 4 compositions out here. And now a question invites itself. Find the formula for A of n. And this is a beautiful activity because it is accessible to almost anyone. Even you may not actually get the final answer, but you can certainly build a table of values, and that is itself part of mathematics. So let's see. For example, for 1, there's obviously only one possible way of writing it. For 2, you can write it as 2 or 1 plus 1, so there are 2 compositions. For 3, as we just saw, there are 4 possible compositions. For 4, there's 4, then there's 3 plus 1, 1 plus 3, then 2 plus 2, 2 plus 1 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2, and 1, 1, 1, 1. And you can count them 1, 2, 3, 4, 5, 6, 7, 8. There are 8 ways. Let's see 5. Well, if you actually sit and work it out, there are all these ways. I won't read it out. Turns out there are exactly 16 ways. And now we see a very beautiful pattern taking place. I'm going to make some remarks about this table itself later. That will come later in the talk. So you see a lovely pattern almost immediately, which is, you'll notice that these numbers are simply doubling each time. 1 goes to 2, 2, 4, then 4, 8, and so on. So they keep doubling, and you will naturally conjecture that A of n is 2 to the power of n minus 1. Now I'm going to just show you, sketch a proof for this. There are probably several proofs of it. I'll just show you one proof, which itself has very important pedagogic value. So let's start with the composition, which has a composition of n, in which there is just one term. So if there's only one term, there's just n itself. For example, for 3, there was just one composition, just composed of 3. Now let's look at compositions which have more than one sum. So obviously it has some first term, so let that first term be k. Obviously k lies between 1 and n minus 1 because there are some more terms after k. So that means what is the shape of this composition? It is k plus a number of other terms, which I've written it as a plus b plus c plus dot dot dot. And those obviously must add up to n minus k, because if this first term is k, these things add up to n minus k. So this part which I have highlighted is a composition of n minus k. And you can see now, by just fixing k, I just give k one fixed value, and I write all possible compositions of n minus k out here. So I'm going to get A of n minus k compositions in which the starting term is k. Alright? So that means this you have this nice recurrence relation, that A of n is equal to 1 plus A of 1 plus A of 2 plus and so on, right up to A of n minus 1. That means A of n is 1 plus every single term before it. And why is that true? So fixing k as the first term, the rest of the terms add up to n minus k. So they are A of n minus k such compositions. And k can take all values from 1 up to n minus 1. So that gives me all these terms. And then there's that one singleton case where the first term was n itself. So you have this. Now in this, if you substitute, replace n by n minus 1. Instead of A of n, you have A of n minus 1. And on the right hand side, the terms go now only up to A of n minus 2. But now if you compare this line and this line, this part here is just the same as this part here, which means this highlighted part is just A of n minus 1. So in short, you will see that A of n is A of n minus 1 plus A of n minus 1, which means A of n is 2A of n minus 1. So that immediately tells you that A of n is a doubling sequence. And therefore, since the first term happens to be 1, you get the required formula. Now this is the precursor activity. Now we'll come to the Fibonacci numbers. So it comes from this thing called the mathematics of poetry. And of course it has become famous now because Professor Manjul Bhargava has given many talks related to this thing. So it comes from this idea of prosody, which is a technical term related to poetry. And it basically refers to rhythm, intonation and speech in poetry. And we now study a problem whose origins lie in that. This is the one which goes back into ancient India. So it has been studied by all such people, Pingala, Virahamka, Gopala, and Hemachandra. The last person is of the 12th century, so in fact they are sometimes called the Hemachandra Fibonacci numbers because of it. So what is the actual way in which this happens? So we consider all syllables, and the syllables are defined to be of two types depending on their length. Either they are short or they are long. Short syllables are considered to have length 1, long syllables are considered to have length 2. And now any word is formed using syllables, and we are categorizing them only in terms of whether they are short or long. So, for example, if you consider words which have only length 1, there is only one such word, namely S. If you consider words of length 2, there are two such words. One is there's a single long syllable, L, or two short syllables which are SS. So there are two possible words whose length is 2. Now again a natural question suggests itself for investigation, which is find the total number of words whose length is n. Okay, I hope the question is clear. So it's just one word of length 1, two words of length 2. So how many words are there of length n? So let that number be called C of n. Now you argue exactly as earlier. And so there's a certain methodology which is coming through. Right? So what's the methodology? You first build the table of values. So we have just seen that there is one word of length 1, two words of length 2. You go on to 3. For 3 you can get, well, SSS is one possibility. Then there is LS, so 2 plus 1. Or SL, which is 1 plus 1. So you'll see the connection with composition. It's very much like a composition, except that you're talking in terms of vowels of short length and long length. So there are 3 such words. In the case of length 4, you can have SSSS or LL, which is 2 plus 2, and then these mixtures, 2 plus 1 plus 1, 1 plus 2 plus 1, 1 plus 1 plus 2. So there are 5 possibilities. And in the case of 5, the number is larger. It turns out there are 8. I mean, you have to actually sit and list all these, make sure you don't miss anything. And by the way, that is also part of mathematics. It's not part of the history of mathematics, but being able to generate the terms of a sequence in a methodical way and making sure you don't miss out something is itself part of the learning of mathematics. So if you do it for 6, you get all these cases, and you'll notice that they have been listed in a very particular way. So look, for example, let's look at the previous one. SSSS is the one at the end. Then SSSL, then L shifts to one step here, then it shifts one more step, and so on. So there's a certain method in the sequence, and discovering the best method so that you don't miss out something is part of mathematics. So you get this nice sequence, 1, 2, 3, 5, 8, 30, very familiar. And I've written down the values here. And these are of course the Fibonacci numbers. So we get the suspicion that we have hit upon the Fibonacci sequence, except that it is a displaced Fibonacci sequence because the Fibonacci sequence starts 0, 1, 1 and so on. So this is like, you have missed out the first 2 terms. But it is the same as the Fibonacci sequence. Now how are you going to prove that it's a Fibonacci sequence? Exactly the same way as earlier. So we say, consider all words with total length n, where n is more than 2. I'm going to only consider words whose length is more than, forget the words which are short. So the last syllable of any such word is either L or S, obviously. So let's delete that last syllable. When we delete it, what's going to happen? If it's an S, you're going to get a word with total length n minus 1 because that S had value 1. And if the last syllable is L, you'll get a word of total length n minus 2. So that's what I've written out here. If the deleted letter is S, the modified word has length n minus 1. Else it has length n minus 2. And in each case, you get all possible families, complete families. For example, let's look at this situation. If you look at the case of n equal to 5, well, there are 8 words possible, that table which we have built up earlier. I'm going to put them, I've colored some of them red, some blue. The red ones are those which end with S. So you'll notice LLS, LSSS and so on. And these all end with L. Alright, so there are 5 out here, 3 out here. Now I remove the last letter of everything and I get this. So from here I get these 5, from these 5 I get these 5 here, and from these 3 I get these 3 here. And these are all the words with value 4. Because by fixing the last position as S, I can make all possible combinations with length 4, and that will give me all possible words which have length, whose length is 5 but which end with S, and same thing out here. So you can immediately see from this that C of n has to be equal to C of n minus 1 plus C of n minus 2, right? It's equal to this length. This here is C of 4, there are 5 such things, and this is C of 3. So C5 is C4 plus C3. So in general this is 2, and therefore you've got the Fibonacci recurrence. So that means the C sequence, it starts with a pair of consecutive Fibonacci numbers, namely 1 and 2, remember the table which we had. And therefore, since the starting two numbers are consecutive Fibonacci numbers, and this recurrence holds, every number is a Fibonacci number. So it's just a displaced Fibonacci sequence. So as I said now, they are also known as the Gopala Hemachandra numbers. Now, before going on to the next topic, let's just look at the possible pedagogical takeaways. First of all, there is the activity of generating terms of a sequence in an empirical way. That is, by methodically listing all possibilities, making sure that you don't miss out anything. So organizing data efficiently is an extremely important part of mathematics. So we don't, we should not have this idea that mathematics only consists in terms of say, methods of learning, proof, and so on. Organizing data efficiently is also part of it. Then having organized data to spot a pattern, that's also part of it. Then formulating a conjecture based on the pattern that you make, formulating a conjecture. Then, having formed a conjecture, to prove it using some method. In this particular case, we use recursion. There may be some other way, but so this is not something in general. This is specific to this activity. But all these are general. And noticing that in these cases, there is no simple formula for the general term, which means we have to generate the terms in a recursive manner. Of course, there is a formula, but we don't have to go into that formula. And there are many variations of the problem that you can explore. So you see the richness of this particular problem. There are all these pedagogical takeaways which expose you to the real, the soul of mathematics, so to speak. So I would conclude this particular part by saying there are rich possibilities, and it is very easy to integrate it into a curriculum. I believe that it needs to be part of our mathematical learning. Now I'm going to move to the next one, which is magic squares of order 3 and 4. And let me start by saying that this would generally be considered recreational mathematics, which is a great pity, I think, because if our intention is to teach ways of reasoning, ways of presenting arguments, if our intention is to become aware of historical themes, magic squares is a wonderful topic. So I've written out here, magic squares have been known since ancient times and continue to be a source of pleasure. There are many beautiful combinatorial properties associated, I think I missed out the word here, number theoretic properties associated with such arrays, some of which can be depicted visually. So they constitute an excellent pedagogical tool. So let's look at the first one, which is, I'm just going to skim over this question of third order magic squares. So supposing you say, I want to make a 3 by 3 magic square using these numbers, 1 to 9. What number occupies the central square, the central cell? So a little, by just, if this particular magic square, for example, is very famous. So you 8, 1, 6, 3, 5, 7. So now this has 5 as its center, and one of the interesting questions you can ask a child is, or a class, can there be any other number at the center of this particular magic square? And sometimes I hear this argument, well, 5 is the central number of 1, 2, 3, 4 up to 9, therefore it must also occupy the central square of this cell of the square. Is this valid reasoning or is it not? Well, it's a case where the final conclusion is correct, but the reasoning is certainly wrong. So let's see what could be the reasoning. I'm going to show you one case of inference. First of all, if you add up all the numbers from 1 to 9, you get 45, which means that the magic sum of this particular magic square is 1/3 of 45, which is 15. Now let n be the number in the center of the square. So m is one of the numbers from 1 to 9. Now we look at different possibilities for n. Suppose n is 9. Suppose this number is 9. If it's 9, then somewhere around it has to be 8. But wherever that 8 is, you're going to get that number plus 9 is more than, that itself adds up to 17, and that's too large. So obviously you can't complete the magic square with a 9 out here. Same thing happens if you put an 8 out here. If you put an 8, well, somewhere around it there's a 9, and 8 plus 9 is more than 17. If you put a 7 here, somewhere around it there's a 9, and 7 plus 9 is 16. If you put a 6 out here, then 6 plus 9 is 15. Again, you already made 15, so you can't put even one other number here. So now you start from the other end. You put a 1 out here, and you notice that somewhere around it there must be a 2, but 1 plus 2 is equal to 3, and you will need a 12 to get 15, and there's no 12 available. So similarly, you can dispose of 2, 3, 4. So you find that the central number cannot be 98 or 9876, and it also cannot be 1, 2, 3, 4. So this is, by strange argument, we have seen that the central number has to be 5. So there's just one possible number in the central square, and after you see this, it's quite easy to construct the magic square. I won't go through that step. Okay, another way, just for curiosity, I'd like to tell you, is this, which is a slightly more mathematical way, which is draw these 4 lines through the central square. Then the total of these numbers which lie on this line is obviously 15, because this is one of the lines of the magic square. Same for this, same for this, same for this. There are 4 such lines. So the total of all the numbers covered will be 60. But the central number now is covered 4 times by all the 4 lines, whereas every other number is accounted for just once. So if you add this, another way of explaining the 60 is, it's all the numbers in the cell, in the square, plus 3 times the number here. So 60 is sum of all the numbers plus 3m, which means 60 is 45 plus 3m, so m is 5. So this is a more algebraic way of getting it. Here is the same square which I just depicted. The person who has played with this square has put 4 such squares together to form a 6 by 6 square, and in an interesting way. Okay, so now what are the pedagogical takeaways here? I have not finished with this topic because I have yet to consider order 4 squares. So let's see what are the pedagogical. First of all, one nice question is, can you have a magic square of order 2? And it's quite easy to show that you cannot. And a nice exercise for a child to prove that you can't have a magic square of order 2. Then an exposure from the proof which I just showed of this notion of proof by exhaustion, which means proof by considering all possible cases. You consider n, the central number could be 9, it could be 8, it could be 7, it could be 6, or 1, or 2, or 3, or 4, and we rule out everything. And having ruled out everything, only one case is left, which is 5, so it must be 5. So that's a style of proof which sometimes will be called brute force enumeration, proof by exhaustion. So this is an important pedagogic learning, one kind of a proof. There are many styles of proof. Some are very slick and very, very neat. Some are of this kind. And there's this, what I just showed you, the algebraic proof, which is much more sophisticated. Then you'll notice if you look inside that square, sorry, yeah, for example, if you look inside this square, you'll find a number of arithmetic progressions here, and they're nice learning out there. 3, 5, 7, 1, 5, 1, 5, 9, 2, 5, 8, 4, 5, 6. A lot of nice arithmetical progressions in that square. And this is an exposure, an early exposure to the subject of arithmetic progressions, because I am assuming that this exposure happens much before class 11 or class 10 when they actually learn about arithmetic progressions. It could happen as early as class 7, for example. A middle school student could easily deal with these questions. Then you have exposure to notions of symmetry. Now, I have not fully exhausted this topic, but I made this, I used this phrase sometime back, that with that 5 in the middle and the numbers 1 to 9, there is essentially just one way of making a magic square. Now, essentially just one means what? Then you can just sort of rotate everything and get another magic square, or flip it over and get another magic square. You get many different possibilities. But actually, you can show that they are essentially all the same. That is, up to rotation and reflection, there is just one. So there is a notion of symmetry concealed in this argument. And then, as I just showed you, there's a possibility of joining 4 such squares to make a magic square of order 6. That is that one graphic from ancient India. And finally, there is this question of magic rectangles, because we always talk only about magic squares. And you might say, isn't there a possibility of having a magic rectangle? And interestingly, you will find that in the young Ramanujan's notebooks, the notebooks that he kept with the pages which he filled in, he must have been very young at that time. He actually considers magic rectangles. He also considers this 3 by 3 magic square. Okay, now this is that same square which I showed you in that graph. Now let's look at magic squares of order 4, much more interesting and also much more complex. And interestingly, whereas there is just one magic square of type 3, there are more than 1,000 of type 4. It's a very complex object. Here's an example of a tricky property that they share. If there's time at the end, I'll show you a proof of it. For any magic square, if you have A, B here and C, D here, then you can show that A plus B is equal to C plus D. The sum of these two entries will be equal to the sum of these two entries. It's a non-obvious result. It takes a bit of proving. Now I'm going to show you something which shows that magic squares have been a matter of interest to human beings for quite a long time. So, I should also say that the same property is true for each pair of symmetrically placed rows and columns and diagonals, which means, now you'll notice out here that you have considered the first row and the fourth row. Now, the same would be true of these two corner entries, instead of the middle two entries, the corner entries of the fourth row and the middle entries of the first row, or the corner entries of the second row and the middle entries of the third row, or the corner entries of the third row and the middle entries of the second row. And there are so many such cases. You can show, for example, that the corner entries of the diagonal, that means this plus this, will be equal to the middle entries of the other diagonal, the sum. So corner plus corner is equal to middle plus middle, and corner plus corner is equal to middle plus middle. There's so many beautiful properties, and you see that in those properties themselves, there's a beautiful notion of symmetry which is coming. So here's something which shows that magic squares have been of interest to people for quite a long time. For example, here, this Renaissance painter, Albrecht Dürer, a painting called Melon, which is a very mysterious painting if you look at it. There's a polyhedron, there's a sphere, there's some strange scales out here. Difficult to know what those scales are supposed to mean. There's some mysterious celestial kind of figure out here. Then this person who is sitting looking rather sad. In fact, he has called this painting melancholia. This person looks very melancholy, sad. And then mysteriously there is a magic square in this. And similarly, in this temple in Khajuraho, there is a magic square. This goes back to the 10th century, so it's much earlier than this particular one. So what could be the interest of these people in magic squares? So I'll show you the same two things a little bit in greater detail. This is the magic square in the Melon Cornea. And what is particularly interesting in this is that this 15 and 14 come next to each other. And Dürer actually made this painting in the year 1514. So he seems to have deliberately selected this magic square. And just to illustrate the property I told you, 16 plus 13 is 29, 15 plus 14 is 29, and then 3 and 2 is 5, 4 and 1 is 5. Let's look at the diagonal. 4 and 13 is 17, 10 and 7 is 17, and so on. And similarly, this magic square from Khajuraho, which is quite different from this. So this is a 10th century thing. So I've shown it, I've rewritten them so you can see it a little bit more clearly. So for this particular one, I'm going to focus on this square a little bit more because it turns out to be not just magic, it's like doubly magic. It's a magical magic square. I'm going to show you why. So why did these people bother to make magic squares at all? And what was the technique by which they generated them? Both questions are of great interest. So let's look at this particular square has been given another name. It's known as a pan-diagonal magic square. And let me explain why. So I have displayed the same thing twice. But in this case, I have colored some entries red. That is this one, and this diagonal here, and this diagonal here. So you notice if you add these, 6 and 10, 6, 11 is 27, and 7, 34. So here you'll find this magic square, everything adds up to 34, all rows, all diagonals, all columns. And now this is referred to as a broken diagonal. That is, imagine, why is it a diagonal at all? You continue this in a straight line, so you'll end up here. But this sort of, it's like a modulo, like in number theory, you bounce back here. So it's like 6, 10, 11, 7. 7 again repeats out. And there is another such broken diagonal, 1, 11, and then coming here, which means it's to say you bounce from there to here, 16, 6. And then 6, if you go down here, you bounce back to 1. So 1 and 11, 12, 12, and this is 22, also 34. So all the broken diagonals add up to 34. So there's a wraparound effect here. So it's a truly, a magical thing. Not only that, but you look at every possible 2 by 2 square. So let's look at this 2 by 2. You have 1, 14, 11, 8. What do they add up to? 15 and 11, 26 and 8, 34. Let's look at this 2 by 2. 8 and 11, 19, 19 and 5, 24 and 10, 34. Every possible 2 by 2 also adds up to the magic sum. So it's a really amazing square. And this square has been of interest to mathematicians since early times. And in fact, the person who worked on this is someone called Narayana Pandit. In the 14th century, he did some pioneering work particularly of magic squares of this particular kind. So in this particular book, Ganitha Kaumudi, he actually describes methods for constructing magic squares of different orders. And then he gives a method for constructing all possible magic squares of the type which I just described. Pan-diagonal magic squares, which have that wraparound property. Now that's quite mysterious how he managed to enumerate. He actually enumerates them all. He gives an argument to show that there are 384 such squares. I am not aware of I'm not familiar with the actual argument that he must have used, but obviously to be able to get that result requires fairly sophisticated thinking to not miss that number. And he also, just to say what all he did, just to show you the kinds of things that were in people's minds. So he not only constructed magic squares, but also various other such figures with circular shape, rectangles, hexagons, and so on. And in one of his books, he actually gives the purpose for studying magic squares. He says to construct something which they call Yantra. And the purpose of this, actually the word Yantra, apparently, I'm not a Sanskrit person, but apparently it means something which gives you a place to rest on. It's like a solid, something to anchor yourself on, to give yourself a hold on something. and this gives you strength to destroy the ego of bad mathematicians, and it's for the pleasure of good mathematicians. He actually declares this. So magic squares were, believe it or not, actually regarded as magical. So they were not, today we regard them as recreational objects, fun for playing around, but they actually were regarded as magic squares, magical objects, and therefore the word magic was actually associated with them with that intention. So for example, if there was a case of poisoning in the family, they would use a magic square whose magic sum is 20. Magic sum 28 used when paddy is attacked by insects. And even magic sum 84 used to pardon children when they are crying. So it's really quite extraordinary, the detail in which they actually sit and make this chart. And I'll show you another such case. This is a person called Nagarjuna. This goes back to the 1st century AD. He gives a magic square, which I've shown out here on the left, whose magic sum is 100. And you'll notice 30, 16, 18, etc. You add up everything, you'll get 100. Now, when I looked at this square, I was a bit surprised. I said, why did he have 100? Why would he make this magic square when all the entries are divisible by 2? Why not just divide by 2? And you will get 15, 15, 8 and so on. Then I noticed that after dividing by 2, the smallest number is 3. So why not further reduce it? So I did some, in fact you'll find if you look at it that this magic square is made up of 4 arithmetic progressions. 6, 10, 14, 18. So you have 6, 10, 14, 18. So it's not a coincidence that 6, 10, 14, 18, each number comes in a different row and a different column. Then you have another magic square, 16, 20, 24, 28. 16, 20, 24, 28. Again, each one comes in a different row and column, and so on. So you'll see how he must have tried to make this magic square. And what I did was I just took these 6, 10, 14, 18, I replaced them by 1, 2, 3, 4. I replaced these 4 numbers by 5, 6, 7, 8. These by 9, 10, 11, 12 and so on, and I got this one. And if this number turns out to be this square turns out to be the regular 4 by 4 magic square. So I find it quite fascinating that this particular thing happened. Now let's check whether this has the pan-diagonal property. Let's see. 15 plus 12 is 27. And these 2 add up to 7, so those 2 you get 34. Then let's look at 10 plus 6, 16, and 7, 23, and 11, 34. So you'll notice that this square has the pan-diagonal property. So he has made a magic square of order 4 with some 100, and it's with some intention. Okay, so yes. So in fact, I have not exhausted the kind of properties this has. You will also notice things like, look at the placement of numbers such as 1 and 16. 1 and 16 lie at the corner of a 3 by 3 square. Right? You'll find that every 3 by 3 square, the 2 corner elements add up to 17. So look at 4 and 13 add up to 17. Or 14 and 3 add up to 17. 9 and 8 is 17. 2 and 15 is 17. 5 and 12 is 17. So it has the most amazing symmetries. So you can see now that bringing this into a curriculum is not just, you're not just playing with numbers, there's a lot of rich ideas of symmetry, ideas of arithmetic progressions. It's a very rich resource. So I'm going to close this particular unit by just quickly breezing through something much more recent, which is Ramanujan's work on magic squares. He has this interesting paragraph in the early part of one of his notebooks, though it's written in slightly different language. Consider 2 sets of natural numbers. S1 is say A, B, C and so on. S2 is P, Q, R and so on, each with n elements. And you take the n squared numbers, which is each of these added to each of these, that is the direct sum of S1 plus S2. Arrange them in an n by n square so that each letter appears exactly once in each row and each column and diagonal. And then we have a magic square. And then of course we must choose A, B, C and so on, so that the numbers out here that you get don't repeat. So he has actually used this formula a number of times. For example, in the case of 3, he takes these two configurations. First, he arranges ABC as CAB, ABC, BCA, and similarly PQR and S, and then adds them, and he gets this out here. You'll actually find this in his notebook. And in the case of one particular choice of numbers, 1, 2, 3, 0, 3, 6, he ends up getting the familiar magic square which we had obtained earlier, 6, 1, 7, etc. And similarly, he also does this with the case of a magic square of order 4, in which he takes ABCD and PQRS, and by adding them he gets this out here. And if he takes this particular arithmetic progression for ABCD and this one for PQR, sorry, this is not an arithmetic progression, but he ends up getting a magic square out here. So anyway, I'm not, this part I have sort of rushed through, so forgive me, but I'm not here, I'm not going to discuss this. But let me conclude this section by looking at the pedagogical takeaways. What would you say are the things which one can really emphasize if we are teaching this as a unit for middle school and early high school children? First of all, it's like an introduction to arithmetic progressions, the properties of APs. Then communicating to children that hit and trial is also a part of mathematics. Guesswork is also a part of mathematics. We should not have this belief that mathematics is just one single line of reasoning which never goes wrong. Absolutely, that is not the case. We have to guess, sometimes backtrack, like in making a magic square. Then this particular pan-diagonal magic square, the fact that diagonals have the wraparound property means that actually if you were to write it on a piece of paper, you can actually fold the paper both ways and get what is known as a torus. So you can actually write the magic square on the torus, and you can see all these diagonals now become continuous rings around this object. So it's a nice introduction to an object which they generally would not meet with at the school level. Then think of the many different symmetries which are there in a pan-diagonal magic square. So many times. I showed them some of them too. And finally, the notion of combinatorics in general. And I should just add this, though I'm not going into that here, that combinatorial thinking seems to have been very, very integrally a part of interest in ancient India. For example, I have come across poetry which is in the form of a square array of letters, okay, say a 5 by 5, and then that same square array, if you move from letter to letter, but not in a linear fashion, from one, in this row by row and so on, but as though it's a knight move. From one, then you jump to something in the second row according to the move to knight, then again jump to the second, third, and so on. You get another poetry which also makes sense. So this kind of thinking seems to have been a matter of great delight to the grammarians and experts in those days, which is about, say, 10 centuries back, 10th, 11th, 12th century. It's unusual. It seems to have been there in part of our culture, of our blood, as you can see. So I'm going to move away now in the last part of this talk, or rather the third part, which is Aryabhata and what I will call the jug problem. Some of you will be knowing that Aryabhata found a way of solving what is now called the linear Diophantine equation. Ax plus by is equal to c in integers, using an algorithm which is called the Kottaka algorithm, which is supposed to mean pulverize, to break something down to bits. And we'll see why that's a good word for it. So it has a very close connection with the algorithm which we teach in school, which is the algorithm for computing greatest common divisor or highest common factor, the division algorithm. Not the prime factorization method, but the division algorithm, in which you keep dividing and get smaller and smaller numbers. In fact, that is the pulverization process. You keep getting smaller numbers. And this has a strange connection with a puzzle involving jugs and water, which I'm going to demonstrate. So what is the jugs and water problem? It's very famous. These kind of problems are very well known. You have a jug with capacity 3 liters, another jug with capacity 5 liters. And then you have a tank with an unlimited amount of water. You want to measure exactly 1 liter using these 2 jugs, and you're not allowed to use estimation. You're not allowed to use fractional filling. So you can't sort of estimate and say, I'm going to just fill half the jug or something like that. So how will you do it? I mean, it's well known. I'm sure everyone here will know the answer. So what is the general problem? Replace 3 liters and 5 liters by A liters and B liters. So you'll be surprised to know that this puzzle actually played a part in some Hollywood thriller. Some of you may have actually seen that film. So here's the Kutaka algorithm. So what is the algorithm? Whenever you have 2 numbers with A greater than B, and you want to find, I've written out here co-prime, but of course that is not needed. You want to find the greatest common divisor. So what is the step that you do? You replace A comma B with the smaller number, that means that comes in front of B, and what comes here is the remainder when you divide A by B. So whenever you have A comma B, replace it by B comma, remainder in A comma. And then of course here, if you assume now, let's assume co-primeness, that means they have no factors in common. By retracing the steps, you can actually find integers x and y such that ax plus by is equal to 1. And of course ax plus by is equal to c, but you can just scale it up by c. So I've given an example out here. This, by the way, is a verse from Aryabhatiya, where this actual algorithm is described out here. If you interpret it, it turns out to be this. So let's take an example. So let's take 10, 7. They are co-prime. So from 10, 7, what do you get? First step, the 7 comes in front, and you divide 10 by 7. What is the remainder when you divide 10 by 7? Remainder 3. So 7, 3. Then at the next step, the 3 comes in front, and when you divide 7 by 3, the remainder is 1. So the next step, you get 3, 1. Then the next step, 1 comes in front, and when you divide 3 by 1, well, there's no remainder. So this is the last step of the algorithm. And whatever number you got here, the front number, the first number, the last remainder out here that you got, that is the GCD. So that's the GCD out here. And now from that, you can recover that, you can solve that equation. So what is this 1 equal to, for example? So this 1 is the remainder in dividing 7 by 3. So it is equal to 7 minus 2 times 3. Then what is the 3? The 3 is the remainder in dividing 10 by 7. So I replace 3 by 10 minus this. And then I just simplify the bracket, and I end up getting, so there's negative 2 times negative 1. So there are 3 7s, 3 times 7, minus 2 times 10. So that's your answer. So xy is equal to negative 2, 3. That is negative 2 times 10 is minus 20, and 3 times 7 is 21. So you get your 1. And this is how the jug and water problem is solved. So now what is interesting is, where would Aryabhata have got interested in this problem? And if you think about it, it's fairly obvious. The interest must have come from astronomy, because astronomy has a very close interest in occultation. Now what is occultation? You have two planets, or a planet and moon and so on, and each is going around in a certain orbit, but those orbital periods are different. So if you start with a position where they are close by, you want to find out the next time how many revolutions each one has to make so that they are again close by. So that is, in astronomy or astrology, it's called occultation. So it's obvious that Aryabhata must have stumbled onto this problem through astronomy. So now let's see how you solve the jug and water problem. So the fact that the first number x, which corresponds to 10, is negative 2, it's minus 2. And the number corresponding to 7 is positive 3. So that means, that tells you that the 7-liter jug must be filled 3 times. And the 10-liter jug must be emptied 2 times. Right? This -2 means emptying, the +3 means filling. So this is what the solution would be. You start with nothing in either jug, then you fill the 7-liter jug once, the fact that the red shows that it is being filled. Then you transfer the 7 into the 10-liter jug, so you get 7, 0. So the notation here is U, V means the 10-liter jug has got U liters and the 7-liter jug has V liters. So 0, 7, then you get 7, 0. Then again fill the 7-liter jug, so you get 7, 7. Then fill it back into this from 7, so 3 liters will come from this and you will get 10, 4. So this will become 7 minus 3, which is 4. Then you get rid of this 10, pour it back into the tank, so you get 0, 4. So you have emptied the 10 once, that is this blue. Then again transfer the 4 here, so you get 4, 0. Again fill up the 7-liter, 4, 7. Then again fill from here into this, so now 6 liters are going to go from here to fill up this, and 1 liter is left here. And then you empty this 10, so you get 0, 1. So you notice 2 of these zeros are there in blue, so 2 times the 10 has got emptied, and 3 times the 7 has got filled. So that corresponds. So you see how the jugs and water problem is solved using this particular algorithm. So the general case, of course, is solved in the same manner. So what is just to list number theory, there are so many such examples, not all from history, I listed a few here. One would be, these are not from historical examples. Can every integer be written as a difference of 2 squares? Can every positive integer be written as a sum of 2 or more consecutive positive integers? Count the diagonals in a convex polynomial. Then what is known as the Tower of Brahma or the Tower of Hanoi problem, where you're moving disks and trying to find a formula. Then I introduced compositions in part 1. Well, we can use variations of it. I had said that at that time itself. Instead of using 1, 2, 3, you can use odd numbers, you can use some other combination. So there are so many such instances. And what would be the main pedagogical takeaway in such a situation? I think, again, there is the idea of recursion which is coming up. There is the idea of explaining GCD. There is a very nice astronomical connection just showing the natural interest that a number theorist would have in astronomy, which otherwise seems unconnected, because you are interested in the orbits of planets and so on. So it's a very rich topic in terms of pedagogy, and I think I have not even listed a fraction of the possibilities. So lastly, I'll make some closing remarks and then we can just have some discussion. So first of all, when you have an exploration, what is the methodology that we need to follow? How do we do it so that there's a real gain coming out of it? Children really learn. First of all, the principle is low floor, high ceiling. This is a term which has become quite popular in recent times. They are also called low threshold activities, which means you introduce an activity which almost anyone can get into because it's very easy to get into it. There's not much background needed. It's just some kind of experimentation, generating figures, generating data and so on. Anyone can get into it and have the feeling that he or she is actually advanced moving. I think the idea of a low threshold activity is very important in our work. Then of course, when we have an activity, we must use simple language. We must be very brief, very concise in our description. We need to frame it in such a way that the student feels invited into the activity. We need to include examples and diagrams and make sure that ambiguities are avoided. And the whole idea is that we do it in such a way that the student, either singly or maybe in small groups, small collaborative groups, they work independently. I think that was also mentioned in the beginning, opening remarks by Professor Vasalwar, that it's very important that we have independent work also be made a part of our learning activities. This is an example of that. So that's why all these are important. To use simple language and not have the child running immediately to you and say, what does this mean? What does that mean? What am I supposed to do? So do it in such a way that they don't have to come running to you. They can sort it out themselves. And finally, it's very important that students develop the habit of keeping a record of all the things that they find. This is a notion which is somehow missing in our mathematics curriculum. To my best knowledge, it was made popular by the great P.K. Srinivasan. He used to talk about the need for having a practical notebook. That is, when you make a note, when you find something through an activity, record it. Keep a record of it and use that same notebook year after year so that when you're in class 9, you may be able to look back and say, oh, I discovered this when I was in class 7, and now I'm seeing this in some other connection. So there's a kind of resonance which happens when you look at your own work. And what's the value of an investigation? I think an investigation, the nature of it is that it is an exploration and pursuit of a question. The end of an investigation is not clear. One may not even know what the end is because you don't prescribe it in advance that you have to reach this particular goal. And the important thing is, when you pose a question, each question leads to fresh questions. That's the very nature of questioning, and we need to encourage that. In fact, one of the great weaknesses of education system in India is that students don't learn how to ask questions. The only questions they ask are clarification. That what is the meaning of that? What is that? What is written out there? Or what am I supposed to do? So just clarification. There's no question of posing a question which is an actual exploration of your goal. So I think asking questions is a very important principle. So chief value to me is this. One learns how to pose one's own questions, how to pursue them, how to explore them, how to organize data, and finally one learns the value of collaboration. Because I think it's very important that these are not just solitary activities, they are done in small groups so that we learn how to exchange data, how to think together. It's very important activity. And lastly, what I said right at the beginning, why include the historical element at all? What's the value of it? I think it's important to appreciate how the subject has grown bit by bit over the centuries. From ancient times, 2005 or 3000 years back, to now, what extraordinary growth it has shown. In every possible field, you look at geometry, you look at calculus, geometry for example. Initially, it was just the geometry of straight lines and points and triangles and so on, Euclidean geometry. And then there's the story of the parallel postulate and how slowly different geometries were discovered over the 17th, 18th, 19th centuries. How it has grown. Or you look at calculus. It has its origins in the work of Archimedes, who showed how to find the area of a surface area of a sphere, the volume of a sphere, volume of a cone, through extraordinarily interesting methods. And some of those methods can be thought of as the precursors to integral calculus. Then there is in Kerala work on another kind of area, infinite series. And then all the work which was done in finding the slope of a curve. There's rich historical element there. Then the way the subject of algebra has grown, the way data analysis is growing in very recent times. Fractal, this is a very incomplete list. One can add some dozens of names and titles out here. And appreciating the fact, as was written in an early slide, that mathematics is made by human beings. It's not just come out of nowhere. Humanizing the subject is another important element, that we bring in our human thinking into it. And also very important, appreciating how something can go wrong when you try to explore the historical element of a subject. You can bring in the notion of identity, identify with certain discoveries and say, this is mine, this is part of my national identity. And I'm sure you're all aware how dangerous this notion of national identity is in today's world. It has caused so much conflict over the centuries, and it is doing so even now. So when we bring in historical element into mathematics, which I think is very important, we also need to do it with sensitivity and awareness that the historical element can get distorted and get hijacked by a different kind of thinking, which we must not permit. So I think it's very important to understand our cultural roots. For example, the very curious fact that in ancient India, they were fascinated by combinatorics. Combinatorial thinking was somehow, they were just in love with it. Magic squares, or you look at, say, Kolam, for example, Rangoli, those complicated designs, which are so, they are given so much importance all over the country. Just like, say, in the Arab world, they were very much in love with mosaic. Mosaic was a matter of great interest. Or in Europe, they were fascinated by mazes and other forms of architecture, cathedrals and so on. In India, combinatorial thinking seems to have been very deeply in our cultural roots. Similarly, in India, we used to love large numbers. It's a very interesting thing. Finding approximate formulas for things. For example, there's the Bakshali formula for finding square roots. It's very interesting that we have this in our tradition. So I've just written out that. And just to close with some quotes, some very nice quotes. Someone who made a presidential address to the Math Association in Britain, he says, I want to talk about the underlying deep simplicity of mathematics and the element of surprise that good mathematics teachers succeed in communicating to their students. Every part of this, I think, is important. The deep simplicity and the connections that are there within mathematics, how different subject areas can connect together in ways which are very surprising. The element of surprise is vital that we communicate as teachers to students. Then a quote from the great George Cornea, there's a grain of discovery in the solution of any problem. Your problem may be modest, but if it challenges your curiosity and brings into play your inventive faculties, and if you solve it by your own means, you may experience the tension and enjoy the triumph of discovery. A very beautiful quote. And the last one, very, very interesting quote. In the long run, it may be more important in the mathematics class how you teach than what you teach. And elsewhere, Polya has also said, you may teach any kind of subject in the classroom, but what you're actually teaching is yourself. You're teaching them what you are, which means if you try to portray something which you are not, try to portray something false, that is really what they are going to learn, and not the subject that you teach. Which is why when we teach, when we bring in the historical element into a subject, it is so important that we do it with the right focus, so that the whole emphasis is on bringing out the beauty of it, the connection with our cultural roots, and not with any other kind of intention. So I think I will stop here. I have reached my last slide, so I will close this window now.
Thank you, sir.
Now we can open up to questions. I would be happy to, for any criticism, any questions. Let me see what you would like to say. Please go ahead.
Yes, thank you, sir, for such a nice talk on the
voice, please.
We are also unable to hear Professor Ashutosh.
The tagline that I thought was mathematics is about its and it is not just straight that pick up it.
Yeah. So you want to ask about the hidden file? Yes. Yes.
Hello. If you want, someone else want to ask questions, please unmute yourself and ask. Otherwise, don't unmute. Okay. Sir, there is one question in the chat box. It is by Dr. B.S. Sudhindra. What books you suggest for liberal maths students?
Oh, there are lots of books. I may not be able to just share some titles here, but I could send to the organizers and they can share with you. But there is a famous book called Mathematics and Its History.
Madhu, you comment that Dr. Madhu?
Just a minute.
Yeah.
Mathematics and Its History by Stilwell. That's an excellent resource. And then there is, for mathematics in India, there is a well-known book by Kim Plofker, which is extremely informative. I can share it separately. I may not be able to give it just off the cuff here. I would be happy to share a list later.
Thank you, sir. Vasalva sir, you are speaking something.
Yes, please.
So what are the historical perspective books on pedagogical methods?
So, I don't think there are too many resources of the kind that you may have in mind. There are books on mathematics and its history. For example, I just now mentioned a book by Stilwell. It's an excellent book on the history of mathematics. And what is important to me about that book is it doesn't just give you a lot of history in terms of this happened and that happened and that happened, but it develops the topic through problems. And I think that many of these things should be done through problems. It should be done through problems which are then posed in an explorative and open-ended way. I think there is also an author called Howard Eaves who does something very similar. He has written two books on historical element in mathematics, in which he develops the themes through problems. So there's a problem sequence. You start with a simple problem, then pose something slightly more general and so on. There's a problem track. So these are very good resources. The books by Howard Eaves, the book by Stilwell, and there are a few more which I will recommend separately.
If chance, please convey in chat or messages.
Chat. We will share what sir is telling, the books names and other things later in all the participants. Along with the final data, we will share the details.
I will do that. Yes.
Any of RI students want to ask question?
Yes, please.
Myself, sir, firstly, the session was very clear, sir, and you made us explain. Sir, I have two questions, sir. Sir, constant and just negative number and optional matrix where positive and positive number. And the second question is, we need a video nationally, so is it possible to teach the magic cubes or magic superposition?
Yes, actually, I'm sorry I didn't catch everything in your question because of disturbance, but you can certainly have, the general understanding for a magic square is that you don't put in negative numbers, you don't even use zero, you don't allow repetition, but it is just an arbitrary constraint that we put on ourselves. We can always You can put in negative numbers if you feel like, because you can always add a constant to everything and then bring it up to a non-negative or a positive. So it's not a very major constraint. And magic cubes, I'm not very familiar with magic cubes myself, but in fact, plenty of work has been done in these areas, magic squares, magic cubes. But my intention was to basically show you some early work done in this area and to explore some of the pedagogic possibilities which I think have been completely left unexplored. Because it's hardly if at all it is just seen as some pastime. There's no attempt to draw some principle out of it, connect it with symmetry, connect it with arithmetic progression, and many other things. I think, to me, that is the important question.
Good morning, sir. This is Ashfaq, student of RI Mysore. Sir, in your talk, you cited an example of Khajuraho temple where magic squares were used in its construction. Sir, my question is, don't you feel it's a high time to integrate the history of mathematics with the mathematics lessons? Because this is most...
Yes, but as I said, it should be done with the focus on mathematics. It should be done with a focus on learning, with the focus on beauty, with the focus on symmetry, that needs to be the core of it. And it should not be done with some other intention. That's all I said. But of course, I agree it should be made part of mathematical learning. And it doesn't have to be the same one fixed syllabus. Different, there's so much of it available. You can do different things. Different people can do different things. But the point is to have that exploration and that contact with history. It's very important.
Sir, my other question is, you are well experienced in the field of mathematics. How do you see the attitude of teachers towards this kind of integration?
I don't think teachers would have a problem, but there's a lot of unfamiliarity. I think there's not enough resources available which are in a form that teachers can use readily. So if we want to do this, perhaps we should prepare more resources. Maybe the education colleges or the maths education people will need to get together and prepare some resources which are usable in the form of little worksheets or there is possibilities.
Thank you, sir.
Sir, there are two questions in the chat box. One is by Mohan Sharma.
Yes.
Why students fear to ask questions in math class? And another one is from Suhas B. Mahesh. Why don't we have a curriculum which includes philosophy of mathematics in at least undergraduate courses?
Okay, 1 minute. The first question I think is not difficult to respond to. Why do students fear to ask questions? Well, one is perhaps they have had bad experiences of being, we have created a culture in which if I say something wrong, it's a matter of shame. Then I feel ashamed and I'm made to feel that something is wrong with me. Making errors publicly, we have created a culture in which there's too much shame associated with it. That's one, I think. And the other is, I think, we have also created a culture in which you just have a question and one answer to it, and you're supposed to get that one answer. Whereas if you develop a culture in which is more exploratory, more open-ended, you can, by asking questions, you can discover something new. And so it's not just oriented towards getting that one answer which is correct, but to discovering connections. I feel any place, any school has the possibility of creating a culture of questioning by creating such an atmosphere in the classroom. And I think it is absolutely necessary that this should happen in our schools. Our teachers should need to take that as a matter of their work. So my work as a mathematics teacher is not just to teach the subject, teach all the topics one by one, but to create a culture in which people feel free to ask difficult questions. Maybe the student will ask a question to which I don't know the answer. I think that culture should also be there. If I don't know the answer, maybe together we can see how we can find the answer. But there is too much fear created around the possibility of making an error. And that, I think, is a profound weakness of our system. Maybe it's there everywhere, but it is certainly quite strong in our country. And the second question that you said, why don't we have a curriculum? I think we should have, but perhaps one problem with most of our curricula are they are too much oriented towards producing results. You go in for research in mathematics and you're supposed to just produce results and publish papers. There's a certain culture which is being created. So when you have a course on philosophy of mathematics, that means you're taking time off to just look at very basic things, ask these things which look very simple but which may not be that simple. So there has to be a certain an atmosphere of inquiry, an atmosphere of calmness. You're not in a hurry to just learn more and more and more and more and publish a lot. You also reflect, talk about things. So I agree with you, it will be good if our BSc courses, not just in mathematics, but even in sciences, well, the philosophy of science, the history of science, where have we gone wrong, why are there so many problems in the world today? Yesterday there was reference to the ecological crisis today. How have we landed up in such a difficult situation? Is that somehow connected with our education system? These are questions which should be part of our science education and our mathematics education. So I agree with you. Yes.
So I think Vasalvasa's connectivity is ready then. Sir.
Any other questions from the listeners?
Sir, good
Am I audible now?
Hello, sir.
Yes, you are.
Sir, myself, Raghu VD, faculty of RI Mysuru. I have one question, sir. Does there any relation between partition of a positive integer and composition of positive integer, sir?
No, the partitions that's a much more complicated topic, because in partitions you don't have order. It's an unordered, you just arrange the largest and it goes in that manner. And the partition function is much more difficult to understand than the composition function. So that's a high level problem, which Ramanujan and Hardy worked on, and they got some fantastic results. That's a very difficult problem. I wouldn't bring that into school level mathematics.
Yes, sir. Thank you, sir.
Thank you, sir. Sir, what appealed to me was your statement about mathematics is about hits and trials, and that particular culture needs to be developed in our school system, where we should not think, the students should not think merely that given one problem is straight.
That's right.
Answering the facts of pain and graduation. That one.
Wait.
Vasalvasa, again some connectivity issues there. So I think, sir,
different present day mathematicians might be working on some other area, but what if Yes, anything, Madhu?
Yes, sir. Again, connectivity problem is there. I think your voice was not audible for some time. Now it is audible.
Now it is okay. Now I just finish my sentence, and then if there are other questions, then we can take up. Otherwise, I think we can wind up the thing. So I just wanted to say that the thinking element goes same, and this needs to be this needs to be seen by the students in our classrooms, and we need to start that particular culture in our Indian classrooms as well. So, if there are any other questions, we can take up. For sparing your time, you are enlightened us. Many of us might start thinking in that particular perspective, which you have. Dr. Madhu, can you hear me?
Sir, your voice was breaking. Sometimes it is audible, sometimes it has some problem. Some network, I think network from that side is very slow, I think. So, shall I
Yeah, it's
wind up that session, sir? I will.
So, but
Vasalva, sir,
yes.
now also it is not audible.
Yes, please.
Okay, sir. It was a wonderful session as we were Shirali sirs, the way the problems, the common problems, which number theory problems were begin, and I enjoyed the beautiful part of it is the takeaway part, the pedagogical takeaway part. Usually problems will be always, we will present problems in the classroom or in the many conferences we have seen problems are presented, but in a conference in NCRT, like NCRT, where most of the participants are teachers and teacher educators and student teachers, we enjoy the part of the pedagogical takeaway instead of, means problems are there are beautiful solutions are there, but we should also want to look into that one in the how a teacher should be use that one, and how the history, and very clearly told how the history should be used in the classroom, not for some other sake, just history for how it was developed. And we really enjoy, sir. There is a lot of questions, queries will be there, but we can, I think sir's mail ID is available with us, we can share that one later. Thank you, sir. Thank you for joining with us in this busy schedule, and thanks for Vasalva sir also for chairing this session. Due to some issue of connectivity, sir could not, some part was not audible. So thank you for all the participants, and now we will break for 20 minutes. Next session 11:15, 11:20 we can join. Thank you. Mr. Anvar Sadath, CEO of Kite Victors from Kerala, is our keynote speaker, and PK Chaurasia sir from RI Ajmer, Professor PK Chaurasia will be chairing the session. I welcome both of you. After the session, we will have a feedback form will be shared. All the participants has to register that one. It will be taken for your attendance also. So over to you, sir. Chaurasia sir.
Thank you. Thank you, Dr. Madhu. So first of all, I would like to thank RI Mysuru to giving me opportunity to chair this session, and I would like to extend my warm welcome to Sri K. Anvar Sadath, CEO of KIT Kerala. So we are proud that we have such a nice speaker with us at this moment. Let me give a brief introduction about Mr. Anvar Sadath. That Mr. Anvar Sadath is the CEO of KIT Kerala Infrastructure and Technology for Education, a government of Kerala enterprise set up to foster, promote and implement modernization of educational institutes in the state of Kerala. He also heads VICTERS educational channel, which was instrumental in providing digital education to 45 lakhs students of Kerala during COVID-19 time. So he has a very wide experience of educational technology in terms of using in the schools, in the school system. And he has successfully implemented the big projects like 493.50 crore high-tech school project and around 300 crore high-tech lab project in over 16,000 schools in the state. So he has a very wide experience about whatever the things he has learned from his experience, he is sharing with us. He is having over 20 years of experience in conceptualization and implementation in the ICT domain, especially in e-governance and e-education sector. He is the first Indian to receive the International Contributions Award given by the Association of Educational Communications and Technology, AECT USA, for his contribution to the field of educational communication and technology in an international setting in 2018. So we are proud that Mr. Anvar Sadath is with us at this moment, and he has such a vast experience of educational technology in so many schools of Kerala. So let's gain, whatever the things he has experienced in his career, he will be sharing with us, and it will be fruitful for all of us. So Mr. Anvar Sadath, I invite you to give your deliberation today. Thank you.
Thank you, Dr. Chaurasia ji, and dear friend Dr. Madhu and other organizers of this great conference. I am also very thankful to RI Mysuru for giving me this opportunity to present the case, especially when the digital education and digital divides have become buzzword or integral part of our educational system after the pandemic, especially after the pandemic. Even before the pandemic, the National Education Policy and the digital education framework, all these were in active consideration for the country. And there were some isolated practices, isolated experiments or implementations happening throughout different parts of the country. From the perspective of Kerala, unfortunately could not have come to RI Mysuru. I would like to have there, because my native place is at Malappuram district near Nilambur. It's close to Nilgiri. So it's around 100 kilometers from there, though I am sitting right now in the southernmost part, Trivandrum. And I have visited RI 2-3 times before for such conferences. But let us see physically next time. Now coming to the topic, digital divide in mathematics, it's a very relevant topic as of now. As a prelude, what I have to say is that the digital divide was an issue which was pertaining alongside of the development of information and communication technology throughout the world. We are hearing about the growth of ICT for the development sector, and that we call it in short form ICTD or ICT4D, that means information and communication technology for development in early 2000, basically. So, many attempts to bridge the digital divide have been done in the country, and one of them, predominantly it was in the e-governance arena, National E-Governance Plan, which came in early 2003 to 2005. Then the Common Service Center project, which was pioneered in Kerala, like Akshaya project. So this was it. So what I would like to begin my talk by saying that handling digital divide is not an isolated activity for mathematics or social science or basic sciences, but it needs a comprehensive intervention for a system to progress further or to capture to reap the benefits of the digital technologies for the betterment of the society, especially in education. Kerala, we have 2 decades of experience in implementing ICT for education. We started in early 2000, 2001 with a project called ITH School, and which was later transformed to KITE, Kerala Infrastructure and Technology for Education, KITE, in 2017. So from the journey has started in 2001, and it has progressive in such a way that after these 2 decades, of this 20 years, we could be able to achieve something, especially even at the time of this pandemic, to bridge the gap, academic gap of students to the possible extent. So before going to my presentation, let me start with a 2-minute video which captures the kite in a very short time. Okay, so as I said, it's almost 2 decades of intervention in ICT education. The basic pillars of any ICT intervention for digital education, especially for our secondary schools, even if it is for secondary or for higher education sector. We have taken these 5 pillars. The most one is capacity building of the existing teachers. We are not taking the foreigners to teach our students ICT. Foreigners in the sense that stakeholders outside the teaching community. So the existing teachers are empowered to handle ICT. So that's a capacity building. And the hardware deployment, which is done in the centralized way, and even for the local mobilization, which is doing content which is more core, which is in tune with the pedagogy and the framework. We are not depending the outside or industry-driven content, but this content is vetted and approved by CRT only is permitted to use in school. And the overall governance, e-governance system for monitoring and for the improvement. And the mode of delivery through which is satellite mode, which is the channel, education channel. So all these elements I will explain in detail while going through the presentation. So the project ITH School was initiated in 2001. Okay, it's 20 years before. And in 2003, Government of Kerala made information technology as a compulsory subject. Initially, it was for class 8. In 2004, it was class 9. 2005, it made compulsory subject for class 10. And information technology was included among one subject for the public examination for the 10th standard. In 2007, we shifted to free and open source software, which was a major milestone for us to achieve up to this level. In 2010, after 10th years, the whole approach has been shifted from ICT to ICT enabled education. In earlier days, the focus was to teach information technology as a subject more of the tools, the operating system, office package, how to make presentation, how to do calculation, etc., etc. But from 2010, the strategy has been changed, and it is like now, instead of imparting skills based on ICT, we use the mathematical issues or social science problem or scientific experiments, and while solving those issues or while giving some softwares for understanding those concepts, the student in turn acquire the skills. So that is what ICT enabled or ICT embedded education. In 2016, the government started a major program called Public Education Rejuvenation System, after which each year almost 1.5 lakh students have started enrolling new, afresh to the public schools in the Kerala. For the last 5 years, it comes around 6 years, it has crossed almost 9 lakhs plus new students. So the high-tech school project, 2017, the government has stabilized the converted ITI school as a Section 8 government company called KAI, which is existing right now. 2020, last year, the Kerala has declared the first state to have complete in the digital education. It was never complete, but in the sense that the whole element has been taken care, and there are further scopes for. So this is the brief outline of this. So what do you say in complete digital education means 4,752 secondary school means class 8 to 12. Classrooms have been put facility for viewing the classes digitally. That means laptop, projectors, and broadband internet with networked classrooms. So 45,000 classrooms is very high-tech school. 8 to 12. This high-tech lab is for 1 to 7. There we are not putting these equipments in our classroom because we don't want the children to use this all the time, but we put mobile sort of labs for them to use for the primary school. And this is the core part. This is Samagra resource portal, which is used to deliver the classes in the smart or high-tech classrooms. So I'll come to that. There comes the strength of pedagogy or curriculum or transactions, which was highly useful in the case of mathematics, which is some brilliant free and open source software available for mathematics. If you ask me which subject do you have excellent packages for demonstrate, the first answer will be for mathematics. Software like GeoGebra, you might have seen that, which is an open source domain, which has been extensively used from class 1 to 12 in our public education system. So there are supporting factors where little kites are equal. It's like your scouts, guides, or MCC clubs. We have almost 1.75 lakh students in 2,000 schools. They do 20 to 40 students per schools. Little kites. They have different activities for dissemination and peer teaching, peer supporting, even training the mothers, sort of thing. So these are ecosystem which put us declared digital education, complete digital education in 2010. Next one, as I said, the capacity building, the empowerment. What all mode of training you have to keep? See, the face-to-face training was or is being followed extensively, but after in the last 4 or 5 years, it has gone to online extensively, even before the COVID. See, in Kerala, we have almost 5 lakhs employees, out of which around 2 lakhs are teachers. That means 40% of our government employees belongs to school teacher category, from classes 1 to 12. and all of them to complete their probation within the 2 years, they have to pass an online course called COOL, Skype Open Online Learning, which is basically a massive open online course, a MOOC course driven on free software and gives the necessary application softwares for a teacher to practice in their classroom, including starting from OS, application packages, video editing, audio recording, cyber security. So all these elements are bundled there. So it's a mandatory for all teachers to pass this course. Government has made it mandatory in 2018. This is the 3rd year. Then different training to Little Kites IT Club. Now it has gone to computer laptop. We have taken a strategy in 2019 that there will be no desktop to school, only laptop. Because of different reasons of power, stability, no need of, it's lightweight, portable, and you don't have any UPS, it has inbuilt charging capacity and all. But of late, we have started mobile journalism, the Mojo training, how to shoot classes, digital classes, documentaries, to make digital content by using the mobile phone, which is all teachers have been given training in a successive ways, which helped us in a big way during the pandemic. Then the visual media literacy, which again have fact check, cyber security, fake news identification, etc. ICT training for mothers. Now, to put earlier days we were saying don't give mobile phone to your kids. Keep phones, mobile phones, smartphone away from kids. But now we are telling them to give your kids for studying later. So what are precautions they have to take? So mothers making them literate on the cyber aspect, that's very important. We use the Little Kites members for the training. So that's ICT training for mothers. Then for online education, we use GSU. It's a new platform which has started from this year. When coming to the digital divide part, I will explain what is strategy we have taken last year and what is strategy we are taking this year. What was the difference I will come to in the later stage, but so Google was closed for training. So these are different types of training for empowering the teachers, students, and even to the states, parents, and other society level. And as I said, the Samagra resource portal. See, you have the digital classroom, you have the digital infrastructure, broadband, internet, networked classroom, projectors, laptops, speakers, etc., etc. But it's of no use if you don't have a relevant content for you to translate in the classroom. So what do you mean by relevant content? There are plenty of apps, tutorials available in the market. So do you want to take some of them or buy some of them or take free some of them and use it and keep your teacher just a operator of that application? No, that was not the way it was envisaged even before the COVID. The Samagra resource portal is what we have taken. We have taken, I will give a demonstration of that if we get the time. It taken each subject for the mathematics. Chapter 1. What are the learning objectives for them? Take one learning objective. What are the macro plan to transact them? For each macro plan, what is the micro plan? List out these, then make the lesson plan, then take the digital resources wherever you require. It's not like scanning QR code and playing some video, identifying some hotspot and playing video. It's not like that. The teacher uses video, animation, images, or interactive applets only where they feel it is appropriate to put in while preparing the lesson plan. So that's the Samagra. It's a different mode which is unique in that sense. And the school wiki is again a collaborative platform for a school or even the alumni to build the content of regarding the school, including the history and the contribution and all. We'll come to that. And we have textbooks. We have ICT textbook from class 1 to 12. Class 1 to 10 basically. We don't have any ICT teacher, IT teacher, exclusive IT teacher for class to 10. That means there are IT period and IT textbook, but the teachers they may be teaching regularly mathematics, Malayalam, English, Hindi, whatever, but they take ownership to teach IT also. That's the way. There is a operating system which is customized by Kite, which bundle all sort of applications which are here for school. So the school don't have to go to install X application or Y application like that, and it's available for users. This is the sort of application. I don't know how much it's visible, but you see it has Office packages, means Office like your Microsoft Office equivalent, Excel equivalent, PowerPoint equivalent, database software. So everything comes under the Office package, LibreOffice. It has like your Photoshop is a GIMP, the software application, like your Inkscape. Then even for Tally, accounting package, we are not using Tally, which is proprietary, So all these TED, Mathematics, GeoGebra, JFraction Lab, Maths Lab, everything is bundled in the operating system and given to schools. So it's not only to schools, even if somebody wants to take it to their laptop, they are free to copy, share and use it. And if they have any problem by installations and all, the schools unit, Little Kites unit or the schools will give the support. So being development that must be. This is the e-governance application, which is supplement to this. I am not going in detail to this part. So this is the, see, whenever we see the digital divide, infrastructure is a major part, which was, there are two schemes, post 2016, the government has announced. One is 493.5 crore high-tech school is for 4752 secondary school, means class 8 to 12. Second one, high-tech lab for 1175 primary schools. The first one was, both of them were, no, first one started with 16, second one 18, but we were able to complete before the COVID, before coming COVID 2020. That is why 2020 October we declared as first digital, complete digital state. And the broadband connectivity, all equipment have 5-year comprehensive warranty. We have call center. If any complaint for school, they can raise the complaint in the call center, or the web, they can call in the call center toll-free number. There is a web portal, and the vendors has to provide support within stipulated time. Otherwise, they will be fined. The system is going perfectly. Even schools where this closure of schools, we don't have much damages to the equipment because of the periodical maintenance and all. And there's the insurance coverage even for theft, fire, and also. This is all comprehensive. You see, you provide equipment, you load all application software required, you provide facility for making their registering their complaint, giving warranty, providing insurance, and guideline for the deployment. So this is the way. So if you see the number, it's 1.19 lakhs laptop, USB speakers, around 70,000 multimedia projectors, mounting kit, HDMI cable screen, a camera, TVs, webcam. This webcam extensively was useful for video conferencing and classes. Cameras used for content development, and TV is have been used for carrying out of Victor's classes. So Victor's, this started in 2006. Basically, it was part of the EduSat, which was inaugurated by Honorable the then President Dr. P.J. Melon. in 2005. Every state has a JUSAT facility at that time, almost all states, and it has both interactive and non-interactive. Interactive means the video conferencing mode. That we have started in 2005. The non-interactive mode, that means it's no, you are broadcasting something from, for example, you are broadcasting classes from Mysore. Some schools within Bangalore, Karnataka or Bangalore, some 120 schools can take those classes by using a dish sort of thing, receive-only terminal. This was the model in 2006. But what happened in Kerala is that in 2009, local cables started carrying this. So we don't have to provide ROT dishes for individual households or schools. Local cables started. 10, 11, and if you take the statistics as of now, almost 93% of the households in Kerala are getting Winter's channel to their house as of now. I will come to how it has come, because there's a crucial part for the digital divide element. And the digital classes first bit. This also started when the COVID came. Here we are starting our classes by 1st June or in a year, because the timetable is like 1st June to 31st March. It's like fashion. But in 2020, when the COVID came, we thought this will be, we need a temporary arrangement for 1 or 2 months. After that, things will be okay. So the first thought came to our mind was to have an online system, because we have this online broadband facility in all schools. But have the facility at school, you have the studio, you have everything, but no, children are at home. So how can we ensure whether they are able to access this or not? That was an issue. So we have decided purposefully not to go for online alone mode, since there are students who are still lacks access for online facilities at that time. Then the next option was the broadcast mode. That means the TV classes. That we took the first build classes through Kite Features. You can see the portal firstbuild.kite.kl.gov.in and the YouTube channel. First it broadcast in the TV, then put in the YouTube or Facebook. The YouTube, it was 33.4 lakh subscribers as of now. It was around 34,000 before the COVID, but now it's 33.4 lakh. Almost 10,000 detail classes have been developed and broadcasted so far. So while starting the classes, the government has issued an order specifying 3 things. One is the digital classes which are being broadcasted through Kite Victor's channel is not an alternate to the existing classroom. It's only an in-dream arrangement. That's number 1. Number 2, which is most important, not even a single student should be left out. That means 100% access should be ensured for all students. Third one, that's also very important. The class teachers have to do the follow-up on a regular basis. They have to provide some worksheets through the social media. If social media is not available in our phone, even if there are children, especially in the tribal sector or in the geographically different terrain, they can make some arrangement to have a direct counseling or nearby libraries or common centers. So these 3 points are important to address the digital divide. That's what I am specifying those things right here. And the second part, ensuring access to all. How we made it. You see, the number of children who doesn't have a TV or online facility was 2.6 lakhs in the May 2nd week of 2020. Then the whole society came forward, non-governmental organizations, and the political parties, local self-government institutions, alumni group, parent-teacher association came forward, and the number was reduced 2.6 lakhs to 1 lakhs. Almost 1.6 lakh students has been provided access within 2 weeks of May. But June first week it was reduced to 12,000, and we could able to bring down that to 0. That means access to all by second week of June. Then only we have started the regular class. It was piloting from June 1 to June 2nd, June first week and second week. So that's all. Local self-government, schools, NGO, they came together. And availability of kite video. It was only through the cable and DTH, cable network earlier. It comes around cable 60 to 65% of households having cable. Remaining 30 to 35% are DTH. It was not available in DTH platform. We have approached all DTH operators and ensured by first week of June that Victors carries in all DTH networks of the in the state. Then you have different dialects. The districts process to Karnataka, like Kasaragod, there are Kannada media. So you need a separate channel for them, and they're narrow cast in their local cable network, not the Victors. And for Tamil, in Palakkad district, close to Coimbatore, and Idiki, Muna, there are Tamil medium school. There also we have a YouTube channel, narrow cast. Then the differently able students, they need a different approach. That is what, when you address the digital divide, it has to be one inclusive approach. So we have 1.25 lakh students who are differently able, and we used 2,500 resource teachers of Samadhi Shiksha, Kerala, and class-specific videos uploaded, and the class teachers, certain cases was differently able means it's not standardized number. So they have to take to their houses and do the demonstration. And for the visually challenged student, they have extensively used this digital platform for the training. For the tribal students, they have classes in 13 tribal languages, which is different from all the Tamil, Kannada, Malayalam, English, all those. For which also we use the resource teachers and videos uploaded in the event. So this is a different approach, different modes of permutation combination to ensure the access and to avoid the learning issues. This is a new approach. As I said last year, we have absolutely gone for digital mode, the transmission mode, the broadcast mode. But this year, we have decided to go for online classes also, because the teachers, the schools, they are getting exact number of students who need online devices, connectivity, and remedial measures started by the government and by the NGOs. We have started a new program called Vidya Kiranam to give devices to the kids. So we use the Google Workspace for education to piloted online education. That means one-to-one interaction. It was trialed in June this year, and for 28 schools piloted in July, and in September started rollout. Right now there are 16 lakh students on this platform and 91,000 plus teachers. Classes 8 to 12. We have not started classes 1 to 7 because online physical classes started in November for all the classes. So priority is given from 8 to 12. We'll come to intervention mathematics. If you want to demonstrate, we have to take more time. There are free software applications which are fantastically fit for the curriculum. So what we have done the approach we have taken is that we have taken the syllabi or curriculum Then take the core team, the teachers team, and with the free software enthusiasts, we set out what all the freely available. So we got J fraction lab for primary, area builder, turtle block, which is like like a game and scratch programming. It's both entertainment and an education tool. So it's a perfectly edutainment platform. GCOM has enormous, even mathematical study, language study, and for differently able kids to stress to get some things and physio game. So these sort of interventions we use in the primary, and which is exactly you can see in the primary textbook called Playbox, which is available in Malayalam, English, Tamil, and Kannada, which is freely downloadable in our website. You have to see the Samagra portal. I will show that. And for secondary level, you all may be familiar with use GeoGebra extensively and open board sort of thing for demonstration and all. If you see the classes of first bell, all teachers use either the GeoGebra open board frequently for translation. Children, they are also familiar with the applets. So applet building competition and all. For higher secondary, it's an excellent initiative by Khan Academy. Khan Academy is a creative common license. It's not like the other proprietary platform which we use for assessment, piloted for some school. Most important thing is that Kerala has introduced a mathematics lab mandatory for the secondary school. So a 12th standard student, while coming out of their board examination, they have to undergo physics lab, chemistry lab, biology lab, and mathematics lab. So 20-25 experiments will have to be practiced by using GeoGebra and other maths lab sort of application, which is also unique in Kerala. You can since you are all mathematics students, you can go through these modules, this syllabi, and we are very happy for getting your feedback and how to improve further on that. So these are the part which you see, this is Samagra portal. Samagra portal means please note down the you have the edutainment component, resources for kids, general resources, question board, textbooks, and I would like to show you the textbooks. For example, if you take the English textbook of class 4 and take the ICT, it's class 1 to 4 is Playbox, and you see how it's arranged. Computer and grandma, find the pins, arrange the numbers, Sudoku, look at the sky, water, data recognition. So basically, this is the ICT textbook, but if you see, this contains the mathematics, science, even languages, which are there in other textbooks. So the find the pins, it's sort of mathematics, and it may be using some peculiar software like Visio game, arrange the numbers. The GCOM is used here. So don't go again. So the software which is used is written right down here. This is OmniText Lite. Balance. This also I think comes under mathematics part. So like this, you can go through the textbooks and some of the resources which are available in Samagra for starting from primary to secondary class. So that is one stream. And the other one I would like to show you is the first bell classes, which again, these are the replica of classes which are aired in PKs. Maybe if you go last year, you take the general medium, and if you are interested, it's not Anganwadi, you take class 10 mathematics, especially in the broadcast mode. But you don't have a way, no other way at that time. So even then, the teacher who have taken classes have assumed that there are some kids in front of them, they are asking questions, so they have to act sort of things. But the softwares, the digital part which they have incorporated in the classroom, which shows the power of free software tools for bringing the mathematics. And emphasizing again and again the free software tool is that our topic is handling the digital divide. So for the digital divide, you have you need the devices, but more importantly, you need the softwares which are available without license restrictions and freely. It's not free of cost in that sense, but now you have to study the source code and you have to customize it based on your curriculum, your pedagogy, your requirement. You have to, the source code are open, you can do the customization. We have done this for GeoGebra and our application. We have customized for our. So I think these are the general things which I want to share with you. Maybe I can have rest of the time. If you want, I can go for QA or round here. Because I feel this one-way traffic like the digital classes, which feels somehow boring. So, sort of getting your feedback and supplementing further.
Thank you, Mr. Anvar. And it's really, your presentation was very sound. It was showing the development which has achieved by the Kerala state. Definitely, Government of India is also trying since so many decades regarding the ICT interventions in school education. And the thing which you have presented from Kerala state, it is showing that Kerala has done a lot of things regarding the ICT integration at school level. The thing which you have shown, Samagra resource portal, pool, everything was really very appreciating, and definitely it shows the dedication, the motivation of the teachers who are involved in the project. And basically, I would like to have the questions first, and whatever the questions is there whatever the questions is there from the audience, we would like to have the questions first, and accordingly we will be discussing further in the session. So, if anybody has the question, they can write either in the chat box or they can speak up here itself, and they can ask their questions from Mr. Anvar.
One question I have already seen, what is the good configuration computer system every student must have? Actually, we don't have a universal configuration system. What we have done, we have taken a Core i3 and Ryzen, AMD Ryzen equivalent system for our project, which is even useful up to this college level. We have tested our applications running and all. But when it comes to massive level, for Vidyagiranam projects, where out of 37 lakh students, the government have identified that 3.7 lakh students need devices. So it has started a program for them to give the devices, wherein cost was a main consideration. So we have taken the minimum requirement of hardware, which even the cell road sort of thing works. At that level, and we have listed out 16 applications, including the video editing and graphical interface, which works on the Celltron system also. So there is no uniform system, but Core i3 will be sufficient for this information for all the applications. But even we have application which works in the normal low-end Celltron machine. Please. I have listed some of URLs in the chat board that you can check. And our general website URL also is there.
session. I would like to, first of all, I would like to appreciate the state of Kerala. Whatever the things they have, whatever the presentation we have seen right now, it is showing much effort, much dedication. This is the good thing which we have seen from the state of Kerala. And actually, if we are looking towards the approach of government of India is launching this, the school at ICT at school. This project has been launched by the government of India itself. Government of India has given so many opportunities to the states, and Kerala has taken most of the benefits of such type of projects which government of India has initiated in the things. So we can see that over the last 2 decades, technology has changed the way world works, and this change has significantly impacted the way students learn and interact. So this we can see here. In fact, our NCRT, the National Council of Educational Research and Training, has long been an advocate of the appropriate use of technology in the classroom. And even in 2005, when this national curriculum framework was released, there was a position statement that it was talking about the role of technology in the teaching and learning of different subject areas. They were talking about so many things in their position statements itself. So basically, what as a participant, what we are looking at the moment, what we have seen in the presentation of the Kerala state, we need to understand the availability of both content-specific and content-neutral technological tools. Basically, whatever the things like Samagra resource portal, if you are looking from the Diksha portal, Government of India has Diksha portal for the use of states, of different states of the teachers. The Government of India has this Diksha portal, like this Samagra resource portal we have for the Kerala states. So content-specific tools include hardware and software, such as there are calculators are there, graphical calculators are there, computer algebra systems are there, dynamic and interactive geometric softwares in mathematics are there, like Mr. Anvar was speaking about GeoGebra. NCRT has also promoted GeoGebra, and the thing they have modified, they have customized the GeoGebra for the teachers of the Kerala state. This is the good thing. Such type of initiatives will be done by I think such type of initiatives should be done by every state. So this is the dedication, this is the approach which we can learn from the Kerala state, and the other state can also follow such type of things. Other people, other resource persons from the other states, they can also promote such type of consolidated effort which Kerala is showing at the moment. Actually, regarding the technology use, some of the things which definitely there are some, pros and cons of the use of technology also, and the way Kerala state is stating that they are looking both the parts. The thing should not be overemphasize the use of technology. This is the good thing which I have realized during the presentation. They are concerned about that the overuse of the technology should not be there. So if we are looking toward the digital initiatives from the Government of India, from the NCRT point of view, so currently several digital initiatives across the world can be seen. In India, the Ministry of Education, web portals and apps like ePathshala, National Repository of Open Educational Resources, NROER, digital infrastructure for knowledge sharing, Diksha, study waves of active learning for young active minds, and massive open online course move like Kerala has Pool, Swam Prabha, a group of 32 DTH channels broadcasting high quality educational content. These have the potential to address the requirements of digital learning. To some extent, we can say that the community of teachers and students, as well as education administrators at all levels can get benefits from these things. So if we are looking towards if we are looking towards the digital resources, there are no, there are enough, you can get enough material from the online resources itself. The resources are there, but the thing is that the way the Kerala has consolidated all the things, we should learn from there, and we can promote these things in our states, in our schools, in our with our children itself. If there is any more questions, we can take the questions here itself. And
hello, sir. Myself Rakshita, and my question is: we see that the online resources it's capable of reaching the more audience on providing sufficient information. But my question is that how can we assess the effectiveness of students learning through online resources?
So basically, the assessment, whether it is online and offline, we can use the same method. Okay, but see, the beauty of or the facility for a digital online space is that if it is tuned perfectly by using artificial intelligence systems or some sort of machine learning, you can analyze the pattern and do necessary interventions wherever required. So that's a value-added thing of that. In this case, in the COVID time, in the initial year, we say 2020-21, except class 10 and 12, all students from class 1 to 9 were not able to attend the school even a single day. So they lost the academic year without attending a single day in classes. They have to depend only on the classes which are coming through the Victor's channel, that is the broadcast mode, which was supplemented by the social media and other support given by the teachers. In those cases, no, we cannot exactly take the assessment or feedback in that person. But what we have done is that we have given the offline mode. We have given the worksheets to the kids, physical worksheets in the last part, which are subsequently connected and done the assessment part. But this time, for classes 8 to 12, we are doing the online mode. There, at least some sort of assessment you can take through the Q&A mode. In a normal LMS, learning management system mode, you can set the questions. If you arrange the questions beautifully, then a good teacher can understand that whichever part the student have to be supplemented further. So that's entire assessment.
Thank you, sir.
Dr. Bitu, okay, sorry. Please go on.
Yeah, no. It was a good question, in fact, and this is the main concern that how to realize the impact of e-learning things. This is the main concern of the day, because in COVID, the things has gone its maximum extent. The use of ICTs, online classes, even in a small village, small school, they are also conducting the online classes by whatever the means they have along with them. By using mobile phones only, they are taking the classes. The thing is that if the things are such in practice at the moment, this is the high time to realize to give basic training to the teachers, so that they can plan. They can plan about how to use the ICTs in their classroom. If they are using ICTs, how this can impact the children's learning. These are the basic questions at the moment.
That's very level. And another question I am seeing from Dr. Biju, what kind of syllabus restructuring and pedagogical framework brought out in the state to make effective use of this initiative? Yeah, basically, if you ask me, the drastic change after the National Curriculum Framework 2005, in the KCF 2007, which was still the fundamental fundamental concept for Kerala, we have put a standard for how to use ICT. It should not be overridden by the curriculum, and that is why we were able to prevent the penetration of market-driven content, industry-driven content, which doesn't have an academic scrutiny. I'm not mentioning any names, any brands which are very famous as of now. We were able to prevent from that and build the alternate with exact in tune with the curriculum. This was very specifically mentioned in the Kerala curriculum framework in 2007, which was followed right now. Right now, we are on a curricular revision, and there the emphasis will be on the possibilities of the digital technologies which you have given, especially in the post-COVID scenario. So where we will spell out where to place this exactly and wherever not to use this. Both we will spell out exactly. So that process has started. Another question, I think to overcome digital divide, we need to improve the infrastructure of public libraries and link them with the community information centers. What are your views on this? Exactly, it's public libraries, because we are now focusing more on school libraries. Even for primary and upper primary is going into class libraries sort of things. Common service center, which I said, which was main impetus for growing e-governance in the country. The whole concept was to make the public spaces accessible more to the common. So libraries and the Anganwadis and the self-help group clubs, which are all placed very, very prominently for getting the digital resources for kids during the pandemic. And that has to be built up further, especially to address the parents. Addressing the parents for equipping them to handle the digital world, digital space issues, cyberspace issues, cyber crime, cyber prevention, and use of overuse issues pertaining to overuse of the digital devices, which are also very important. So that is why the media literacy or digital literacy sort of things been planned extensively for parents in the states. So any other questions?
Yeah, no, actually not questions. Actually, I just want to tell only one or two things. Actually, other states. Actually, when we designed the conference, we were planning to have more interaction with other states also, because Karnataka also they are using TV channels for teaching. They do the Chandana channel and other channels. Andhra also they have Andhra and Telangana. South Indian states they were using that one. So I hope there will be a discussion in further also in some state. People can tell their how their effectiveness and what are the problems they were facing here, and there are some relevant issues they were raising. One is about the assessment. I think during the pandemic period, assessment was a big issue, and the whole concept of assessment is a very big thing. That means how to assess and why we should assess is a very big question, and we are in a way of our old type of memory testing level to change when you are coming to that. That was a problem I think they were raising. Another one they were telling was when you come to the online scenario, all the states had faced the problem which Dr. Biju was raised. That was what are the pedagogical framework, whether we instead of simply shooting something in front of the classroom, any changes or pedagogical aspects, whether we are focusing, those things are actually require a lot of time of discussion and debate and bring up this one. So this presentation should be one space or one what is that groundwork we can have on that one. So these are the one or two things, and I want to tell sir, ask sir about the tribal languages. I think sir has not mentioned that, because a lot of places sir told about Kannada medium schools in Kerala and Tamil medium schools in Kerala. How they were handling this language was a barrier for them. Because Victor's channel, which I watched, was Malayalam, almost a standardized language they were using, standardized one. but they were using the tribal, what might be happening in the tribal areas where connectivity was less. So that is only one question I want to add to that one, sir.
Yeah, in fact, the two parts, the pedagogical part, I will make it clear very now. It was a big challenge for us, how to do the transaction, because we don't want to set a model at that time, because this is a model class, this is the things, this is a class which has to be followed further. So you should be very careful in handling that. We have taken 2-3 examples, 2-3 models, and that's what the teacher assumed some students in front of them, and they were responding to some questions which are expected from the classroom. So it was not an easy job. We prepared the script, and in the script which was approved by CRT, as long as the pedagogical perspective has been put, even if there are limitations for making in a broadcast mode, then do that. But it became a hit in that per se, because the first classes like Tangu Pucha and Mittu Pucha, certain classes have seen more than 60 lakhs views in YouTube, besides the classes. So, and in June, July 2020, we have got 160 countries views. And with regard to running a TV channel, the things which are here, I said, it's the availability, that's very important. We have ensured it is wherever a household have access to TV, anyway, it's through DTH or cable or some net, Victor should be in there. The state government education channel should be there. So that has been ensured by 2020 June 1st week. 93% of households have cable access, TV access as of now from Kerala. 93%. All these 93% carry details, which is not the case in other states. That is the challenge for them, because we have been contacted by other states, but no, they access percentage comes 10, 15 or 20% like that. This has to be increased. It's not easy, but no, that has to be done, because we have to now prepare for this sort of pandemic, and this is only a stopgap arrangement. We don't think much about the assessment and whatever we do in a normal classroom transaction, we don't think, because this is only to bring the academic loss, to reduce the academic loss. And loss is there till you have the physical classes. Okay. And when it goes to online, then the pedagogical practices now has to be adopted little much, but then access is an issue. So you have to balance it between. That's another. Second one, for tribal dialects and tribal languages, I have seen, I think I have made in the slide that beside Tamil channel and Tamil YouTube in separate Kannada, we had this whiteboard for differently abled kids, and 13 tribal languages, the classes have been put in 13 tribal languages. We call it Milipur. So it has been loaded there, and it was not online. It was loaded in the laptop and taken to their colonies by the resource persons and tribal facilitators. But really there are losses in those sectors. Some of them was done to a manageable level, but there are locations where there is serious losses happen for the sector, the tribal area. They came for some times, but when they lose the passion, it's very difficult to bring them again to the classes, which we are now intensively after the school reopen, we are intensively focusing to give the supplementary sort of intervention for them. Because the major bottleneck for the tribal students here is that the residential schools were closed actually. Because they live in a very remote location, and their own learning process, schooling process has been in the hostels, basically, the tribal hostels, just provide all facilities there. So that was a gap, but we have tried to do some classes in tribal languages, but those not.
regarding this pedagogical framework, like Dr. Viju has raised the question and Dr. Madhu has also was discussing about it. The basic thing is there is a area TPCK. You know that technological pedagogical content knowledge. There is a huge area, and lots of work has been done in this area itself. And how this overlapping of technology and pedagogy, how this is affecting the content knowledge. And if I mean viewers are interested to look into details of these things, they can look into the this theoretical framework of TPCK. They use lots of things are available on the net also, and how these are being implemented in the content. Suppose I am taking the content of the mathematics itself, and there is a well set pedagogy for the teachers that if they are teaching the fractions, if they are teaching suppose circles in their classroom, they are taking some pedagogical since long they are taking those pedagogical steps for dealing the concept itself. But when you are introducing the technology, like you are introducing the GeoGebras there, so GeoGebras introducing of the technology is impacting the pedagogy also. The pedagogy is changed, the way of questioning is changed, the way of presentation is changed. So all these things can be if you are looking towards the detail of these things, you can go through the theoretical background of this TPCK and then try to implement in the content which you are looking which are in the practice at the moment. And the thing is that whatever the presentation we have seen from Mr. Anvarji, in Kerala they have taken care of all these things. The content, the existing pedagogy, and when the technology is coming, they have given the impact of the technology in the execution of the pedagogy also. That is the nice thing, and it should be replicated to everybody. It should be replicated to every state, and every state should learn. The things should be consolidated in such manner. Any more question? Mr. Siddharth Kumar Singh has written that as you are telling that both online and offline classes are effective, from my perspective, I am an offline class. The teacher can interact and see the students' facial expressions to understand whether they are following or not. But how can this be accomplished in an online class? And the students have to sit for long hours. Can an online class be more effective overcoming these issues? So that is the thing. See, real classroom cannot be replaced by the technology. This is the first thing you should note it. Whatever the real practice, face-to-face teaching is there, blackboard teaching is there, and you are using technology in the real-time classroom, that cannot be replicated by any online classes. So, if you are in the online classes, your way of interaction, your way of assessment, everything has to be modified accordingly. There are new technology available, there are new softwares available, there are applications are available, learning curves of the concepts are available. You have to go through those things, and accordingly you have to plan your assessment also, if you are looking the learning curves of the students itself. So I think there is no more question now. Dr. Madhu, you can take over take over the session and whatever the concluding remarks you have.
Thank you, sir. Thank you for this. Lot of interaction were there in this session, because digital divide is a very serious issue. Our students and many teachers are faced this one in a real situation. What is the difference between virtual classroom and real classroom? They are feeling actually, and I think in the beginning itself it is told in what happened in the recent period. All over the world they were thinking of it as an interim arrangement, but it am I audible now?
you are audible. You are audible.
So all the world has faced this issue, and education sector is affected with the pandemic in a very severe way. But now we are coming back from that one. But at the same time, it has some advantages also, like the states have developed their own videos, their NCRTs developed their own videos, and when we are earlier we are telling about the flipped classroom and other things, people were not ready to accept that one. But now this is the situation, people are ready to accept. And when we are teaching in classroom also, students are in such a way that they are even the small children, they will go to the YouTube or go to the other kite pictures or any whatever channels they are available, they will explore there and they will tell that already we have seen this class, or some discussions was happening in the classroom by what they have observed. So this was a very effective session, and there will be a lot of discussions will be following this one. So thank you Anvar, Sadath sir, for giving your valuable time. Even though sir told 20 minutes presentation, it was a bit of interaction. It almost 1 o'clock is almost nearing 1 o'clock. So thank you sir for spending valuable time with us. Also I would like to thank our chairperson Chaurasya sir also. Thank you sir for chairing this session, and all the participants also I thank for the time being, and we will break for lunch. And next afternoon session will be paper presentations, and paper presentations links have been shared in the chat box. So kindly join on time. We will be beginning little early, around 1:30 we will begin the sessions, paper presentations. So kindly be ready for that one. So there are 3 parallel sessions are going on. One is in the Cisco only, that is 2.1 will be here, Cisco, same link. 2.2 will be Google Meet, 2.3 is also in Google Meet. So we will hope all of you can join that time. Thank you, and there is a feedback session is there. Kindly fill the feedback session for this session, feedback form. We will take it for your attendance also. Thank you once again everyone. Thank you sir.
Thank you. Thank you.